We have some tricks for calculating integrals involving powers of secant and tangent, but unlike the sine and cosine case, for the tangent and secant case, we don't yet have enough tricks to cover all possible cases. So if you can arrange to have one secant and one tangent, and everything else secants, you're good. If you can arrange to have two secants left over and everything else tangents, you're good. But that doesn't cover all cases. Here's a case that doesn't handle, just secant cubed x dx. If we set aside a secant squared, we're left with only one factor of secant, which we can't turn into tangent in any nice way. And we can't come up with secant times tangent because there's no way to get just one factor of tangent. So those u substitution tricks don't really work for this example. And there are other examples like this where just the u substitution tricks won't help. So what do you do in these situations? Well, we don't have any identities we can use because the Pythagorean identity doesn't help. There's no u substitution, no obvious u substitution to try, so, we're kind of in a tricky situation here. Really, the only other trick we have up our sleeves is integration by parts, I guess. So if we did integration by parts, what would we use for u and what would we use for v? Well, one possible choice for u is just to take u equals secant cubed, and then dv is going to be dx. But this is going to make matters worse and not better, because when we calculate du, we're going to get secants and tangents, but also when we integrate v, we're going to get an x. Now we're getting a mix of polynomials and trig functions. This seems like a really bad idea. So let's back up. If we're going to do integration by parts, we need to somehow split up secant cubed so that part of it is nice to integrate. And one way to do that is break it up into secant x times secant squared x dx, because secant squared is nice to integrate. So now we can take u to be secant x, we can take dv to be secant squared x dx, du is secant x tangent x, v is tangent x. Okay, now we have, let's see, so u times v, secant x times tangent x minus the integral of v du, so secant x tangent squared x, right? One tangent from v and a factor of tangent coming from du. Oh, I've missed my dx here. There we go. dx. All right, so as usual, integration by parts has turned one integral into a different integral. Is this integral any better? It's hard to say. What could we do with this integral? Well, we could turn these tangents back into secants using the Pythagorean identity. But if we do that, we'll end up with a secant cubed. But that's just going to give us the integral we started with again, but with a minus sign. And if we have the integral we started with on the right with a minus sign, we can solve this equation for this integral. So let's do that. So we get secant x tangent x minus the integral of secant x times, so tangent squared is secant squared x minus 1 dx. All right, and so this is all equal to integral of secant cubed x dx. So integral of secant cubed x dx is secant x tangent x minus the integral of secant cubed x dx, sorry, secant cubed x minus secant x dx. Okay, now let's break up this integral on the right hand side. So secant cubed, integral of secant cubed x dx is equal to secant x times tangent x minus integral of secant cubed x dx plus integral of secant x dx. All right, now finally we can take this negative secant integral secant cubed and move it to the left. We get 2 times the integral of secant cubed x dx is secant x tangent x plus integral of secant x is natural log absolute value secant x plus tangent x plus a constant, and then finally divide by 2. So the integral we wanted, integral of secant cubed x dx, is 1/2 times all this stuff, secant x tangent x plus natural log secant x plus tangent x plus a constant. Okay, so the point of this example is not, this is not a formula that you should remember, right? If you ever need to know the integral of secant cubed, I would recommend you just look this up because secant cubed doesn't show up that often. But the point of this example is that the u substitution tricks we have for secant and tangent don't always tell the whole story, and sometimes you need to be flexible and try something else. Something else in this context usually means integration by parts. And these integration by parts situations with secant and tangent can turn out pretty messy. But fortunately, they also don't show up that often.